for Chapter 9. And as you can see, Chapter 9 has been split apart. So we will have a summative assessment on 9.1 through 9.4, and then another summative on the latter part of the unit. Chapter 9 is getting into the fun stuff of algebra. This is a really big building block for Algebra 2. And also everything we do in Chapter 9, we're going to undo or work backwards in Chapter 10. So it's super important that you pay attention to Chapter 9. There's a lot of shortcuts that you're going to learn in the latter part of the chapter, and you will need to understand those shortcuts for Chapter 10. So we're going to try to take it nice and slow here so that you get a really solid foundation and then can be super successful with the rest of Chapter 10 and also in Algebra 2. The first thing I would suggest for you is you get some different colored pens, markers, whatever. There's a lot of vocab, as you can see at the beginning part of this chapter in 9.1, and that's because we need to understand all of these terms because we're going to be using them every day from now on. So the first definition we have here, and you'll need to be pausing because I probably won't go slow enough for you to write it all down and listen at the same time. A monomial, so practice saying that, monomial. It's a number, a variable, or the product of a number and one or more variables with whole number exponents. Okay, so we're going to kind of write down the definition, and then off to the side here where it says your notes, we'll do some examples. A monomial could just be a number, like 27, -2, so on. It can be a variable. It could be x, z, and so on. Or it could be something that is a product of those. For example, z squared is technically z times z. That's still a monomial. 3xy is a product of numbers and variables. As long as the exponents are whole numbers, I could add like a 3 and a 4, that's all still a monomial. Basically, there's no adding or subtracting going on. The next definition is a degree of a monomial. The sum of the exponents of the variables in a monomial is its degree. So, for example, the degree here of z squared is 2. The degree here of this monomial is 7. We do not count the exponent of the coefficient. 3's exponent is 1, but to find the degree, you only add the variable exponent. So the degree of this guy is 7. 3 plus 4 is 7. A polynomial, say that one, polynomial, it's a monomial or a sum of monomials. So it could just be one of these. We could say this is a polynomial. It's like the broad spectrum. Or we could add a few of these together. So 2x squared plus 3x plus 7. That's a polynomial. It's many terms added together. Many monomials added together. The degree of the polynomial is the greatest degree of the terms. So each term has its own degree, remember? Degree of a monomial. What's the degree of this guy? 2. What's the degree of this guy? 1. That's like x to the first power. What's the degree of this guy? 0. It doesn't have any variables with exponents. The degree of the polynomial is the greatest one. So the degree of this polynomial is 2. Now, if I had 3x cubed y to the 4th at the beginning part of this polynomial, then the degree of this guy would have been 7. Okay, the leading coefficient is the coefficient of the first term in a polynomial that is written with the exponents of a variable decreasing from left to right. Okay, so what does that mean? Here's my polynomial right here. I have written them with my exponents of my variable decreasing. X squared was the highest degree, x to the first, and then this is technically x to the what? It's x to the 0, because any number to the 0 power is 1, so that's really just 7 times 1. We don't even write it then, it's just 7. So I have written this in decreasing order, like I was supposed to, So what is the leading coefficient of this guy? That 2 right there. That's the leading coefficient. All right, the last two vocabs are short and sweet. A binomial, that's a polynomial with two terms, like bicycle, two wheels, binomial, two terms. A trinomial is a polynomial with three terms. So a tricycle has three wheels, trinomial has three terms. This was a trinomial right there. There were three monomial terms in that binomial. All right, so if it seems a little confusing and you're already getting mixed up, no problem, because what are we going to do this whole unit? Keep using these terms over and over to help you understand them. So let's look down here at example, right? Example 1, it says rewrite a polynomial. So they have given us a trinomial, actually. It's a polynomial with three terms. We need to rewrite it so the exponents decrease from left to right, and then identify the degree and the leading coefficient of the polynomial. So the first thing they've done here is they want us to identify the degrees of each one of those terms. The degree of this guy is 0, because this is x to the 0 power, just like I showed you up there. That's a 0. So that degree is 0. There are no variables with an exponent. This degree is 4, and x is to the first power, so its degree is 1. So I need to write them so they are in decreasing order. The greatest one was 4, so that is 2x to the 4th. The next one is the degree of 1, so it's minus, because this minus sign is linked to this guy. It's minus 4x, or you could have made it plus a negative, so you linked it even more. And then it's just plus 7. And we don't really write x to the 0 power. That's too much writing for mathematicians to write that. We just know it's 7. The greatest degree is which one? It's 4. So the degree of the polynomial is 4. We don't add them all up together. It's just whatever is the biggest one. It's 4, done. The leading coefficient is what then? The 2 out in front. Okay, the next page in your packet is actually blank here. It's blank in case we need to add in some PODs. And so then we're at the checkpoint. So what you're going to do right now is pause the video. You're going to do just what I did in my example. You're going to identify the exponents and write it so that they decrease from left to right. Then what is the degree of that polynomial, and what is the leading coefficient? So go ahead and pause and try that out, and then come back and see if you got it right. All right, so here are your solutions. Number 1 is 8x cubed plus 5x plus 13. The degree is 3. The leading coefficient is 8. Number 2 is negative, do you have the negative there? Negative 7y to the 5th, because there was a minus sign in front of that, so I made it plus a negative to link it together, plus 4y to the 4th plus 2y. The degree is 5. The leading coefficient is negative 7. All right, so pause here and see Mrs. Wyman if you happen to be in school, if you're having problems. Otherwise, you can continue on. If you're at home, just see me tomorrow. Example 2, you're going to identify and classify the polynomials. First, you're going to tell whether the expression is a polynomial. Does it follow the rules of a polynomial? If it is a polynomial, then you're going to find its degree and classify it by the number of terms. Otherwise, if it's not a polynomial, you're going to tell why it's not. Okay, so number 1, is that a polynomial? Remember, a polynomial can just be a monomial, and a monomial is a number, a variable, or a product of those. Is that a number? Yep, it is. What's its degree? Well, it doesn't have any variables, so its degree is 0. It's like x to the 0 power there. All right, is the next one a polynomial? It is not a polynomial because it has a negative exponent, and the definition of a polynomial was that it was a bunch of monomials, and they have to have whole number exponents, and whole numbers are not negative numbers. So we're going to say no, this is not a polynomial because it has negative exponents. All right, the next guy, they filled in the yes. Yes, this is a polynomial. What kind of polynomial is it? There are two terms. So it is a binomial. And what degree is it? It's the third degree. The greatest power was 3 there, so third degree. All right, the next guy is not in descending order, you'll notice, so it's a little bit tricky. This is a polynomial. It's a trinomial. There are 3 terms there being separated by adding and subtracting. However, its greatest degree should be up at the front, and it's not. So this is the 4th degree. Okay, the last one. Is that a polynomial? Nope, not a polynomial. Why not? Does it have a whole number exponent? Definitely not. It has a variable exponent. So this is no, it has a variable exponent. All right, we're at the next checkpoint. Go ahead and pause, and then come back and see if you got them correct. Okay, number 3 is a polynomial. Its degree is 7. That was the highest power right there. And it is a trinomial. Number 4 is not a polynomial. It has a term with a negative exponent. Okay, so the next page is our last page of notes, and we are now going to add and subtract our polynomials. All that talk about the degree was very important for adding and subtracting, because when we add terms together, terms that have the same variable with the same degree, the same exponent, can be added. They're like terms. Other terms that don't have the same variable and the same degree are not like terms. So in A, we're going to take A first here. They want us to add this trinomial to this trinomial. They're going to show us 2 different ways to do this, a vertical format, and then the next example, they're going to do the horizontal format. In the vertical format, you add these up in columns and you put them over terms that are alike. So the cubed terms was the 4x cubed and the regular x cubed. And what's the coefficient of that guy? A 1. They were lined up together and they make 5x cubed. You add the coefficients, the exponent does not change. It's like saying 4 apples plus an apple is 5 apples. The label is the x cubed. Okay, the next item, and you can notice here what I'm starting to do is use coloring, because that's the method of my choice, is actually to color these each time and add them together. I have an x squared, it's like a 1x squared, and I have a negative 3x squared. So if you need to make this plus a negative to help you with your integer operation, go ahead and do that. It's 1 plus negative 3, which is negative 2, or minus 2. You can make it plus a negative. You could have left it as minus. So it's negative 2, and then the label is x squared. The next term in descending order is a 7x. But look at over here, there is no 7x. They don't put it, they just kind of leave it as an open spot there, and I just write plus 7x. The final term in my equation is a negative 5. It's a minus 5 there. You know that's plus a negative, so I can write plus a negative 5 or minus 5. I've now added my 2 trinomials together, and my answer is in descending order like it needs to be. Highest exponent, a whole number or an integer, always goes at the end. All right, the next equation that they wanted us to do, or the next problem, is right here. And they want us to use the horizontal format. So what they're going to do is they're going to group like terms together. So I'm going to first find the highest ones, the highest degree. I have an x squared and an x squared. So that's 1x squared plus 1x squared is 2x squared. Then I have a degree of 1. I have a plus x and a minus x. So that is a 1x plus a negative 1x, or you could write minus x. Plus negative 1x is what I'll write. What happens to those two? They become 0x. So would you write 0x, or do you need to just write 0? Actually, you don't need to write anything at all. It's just gone. These have canceled out. The last one I have is I have plus 8 and minus 1. So I can write 8 minus 1, or 8 plus negative 1, which is 7. So plus 7. All right, so stop the video, go down to checkpoint number 5. The best way that I advise doing this is actually with the color coding, and then you can put them in a vertical or horizontal. As long as I see color coding, that's enough work for me. If you want to do vertical or horizontal, definitely go ahead. Okay, your solution should be 12x to the fourth plus 5x cubed plus negative 3x squared minus 1. And if you have minus 3x squared, great. You'll notice in the x squareds, I made them plus a negative 2 and plus negative 1, so I didn't forget about that guy. Negative 2 plus negative 1 is negative 3. Okay, the last thing we need to do is work on subtracting our polynomials. And here's the big thing to remember. This subtraction sign is on the outside, which means every term here is going to be subtracted. Every term, which means you're going to do the opposite of the sign that it currently has. So they have vertical and horizontal solutions again. It's two different problems here, so we're going to work through. They have it set up vertically by the degree, and basically what I'm going to do here is I'm going to do the opposite of each one. So I'm going to change this to adding, which makes this plus 2z squared, plus negative 5z, and plus a positive 1. So really I have 4z squared plus 2z squared minus 5z, or plus a negative, and then the negative 3 on top gets lined up with the plus 1 now. So that is 6z squared minus 5z minus 2. All right, lining them up horizontally now. What they're going to do is first actually distribute this negative sign to each one. So they're going to go plus, negative, positive, positive, and rewrite it that way. So this is plus a negative 1x squared plus a 1x plus 7. Then they want you to regroup them so that they are next to their like term, their exponent of the same degree. I'm just going to use my color coding here and get my final answer. So I have a 3x squared and a negative 1x squared. They make 2x squared. I have a 6x and a 1x, which is 7x. And I have a negative 4. Remember that guy's a negative. So it's plus a negative 4. And a positive 7 is a positive 3. And that's as far as I can go. I can't do anything until somebody comes along and says, oh, by the way, x is this. Then I could plug it in and do order of operations to get a final answer. All right, last one. Pause the video, do number 6. All right, so let's see how you did. It's negative 10t to the fourth plus 6t minus 5t. The biggest common mistake is just distributing this minus sign or this plus negative 1 that's out there. You're multiplying negative 1 to each item. People will forget and they only do it to the first and not to the second. So because we're distributing that negative 1, this became a positive. So those t squareds got added together. Oops. And it should be 6t to the second power right there. All right. The minus 5t can be written as plus negative or minus. So go ahead and see me if you need any help. Otherwise, you're moving on to the next step, which is the practice on 9.1.